So this is the second of two videos that takes us through an introduction of conditional statements. So if you just clicked into this one, you'll find a link at the bottom of the screen which will take you directly to the first one if you're interested. So let's look at an example of an if statement. So we have some integer a is equal to 9, some integer b is equal to 12. We simply say if a is less than b, we print out a is less than b. That's the condition. That's the statement. Here's an if-else structure. If a is a is 9, b is 12. This is the condition that's evaluated. That's the true statement. That's the false statement. So now if we look at this one. So I want you to take a second and look at this. I want you to see if you can see something wrong here. So this would compile and run. My question is, what's the logic error here? Well, let's ask ourselves. First, if a is less than b, we do a is less than b. If a is greater than b, we print out a is greater than b. If a is equivalent to b, we print out a is equal to b. Else if a is not equal to b, we print out not equal to b. So there's a couple things wrong here. But the first thing I'm going to talk about is, notice how if a and b are integers, these four are the only possibilities. So that means one of these four conditional statements has to be evaluated true. So therefore, the first thing I would kind of catch here is that since one of these has to be true, I would actually make the last statement an else. There's no need to evaluate some sort of conditional logic there. And so our diagram goes from this, so check condition, statement. If it fails, check this condition, statement. If it fails, check this condition. If it fails, check this condition. Since one of these I know has to be true, it's a little more efficient, well it is more efficient, just make that last statement an else statement. My question is there still a logic error here? And in fact there is. This else will never actually be reached, because if a is not less than b and a isn't greater than b, then a has to be b. So this else statement is fine. It's not going to actually cause a problem, but it will never be reached. So ideally, we want to kind of identify conditions that will never be reached and remove them. So that would be a better way to write it. Now, of course, you'd have to figure out how you want to communicate a and b in terms of how they relate to each other. But the point here is that if you have a condition that's never going to be reached, take it out. And notice how the last statement goes from an else if to an else, because since if this fails and this fails, this has to be true. So this is a really common logic error. Can you see what the problem is here? This would run, no problem, but there's a problem. So let's look. So we create a scanner, we make a character, and we basically take an input for that character. And I say if opt is equivalent to a and opt is equivalent to small a. The variable opt can only hold one variable at a time. Therefore, it can't be both capital A and small a at the same time. It's not possible. Therefore, the Boolean expression would never evaluate to true here. So how do we fix this logic error? We make it or. Watch right here. Ready? It becomes or. So you're going to find as you start using these and and or operators, you're going to have to watch for logic errors. Those are really annoying errors that your program will run. It just won't run properly. It's always a good thing if you're having some problems. Don't be afraid to share your code with a friend of yours or your teacher and ask them just to check it out. Because sometimes you can spend hours trying to look for some little small mistake and not find it, and someone just with a fresh set of eyes can pick it out right away. Another common error that students will make is they'll put a semicolon at the end of an if structure. Often that will compile, but it will compile incorrectly, so that's another one to watch for. So this is an operator a few years back a student started using, and I figured I better learn it. This is one of the reasons why I love teaching computer science, because I'm always learning new things. Um, the question mark operator is a way of condensing a conditional statement into one line. So essentially it works like this. If you put a condition and then a question mark and then the true result and false result, what it will do is that it will evaluate this condition. So here I see A is greater than B, and then if that's true, I'm going to print out, I'm going to take A, and if it's false, I'm going to take B. So this is a way of evaluating a condition and then generating a true and false result in a very condensed space. That's a nice one to keep in the back of your head. So now let's look at some multiple choice questions, and let's put this into practice. So we want to state the value when the below code segment is done executing. So if we look at this, one thing we always want to do is we always want to check and make sure we understand how these are connected. So since we have our opening if statement here, and we have an else if, else if, else if, else, this is one big conditional block, meaning that if at any point along the line one of these evaluates to true, I'm out. So, start. Is -1 less than 0? Well, that's true, so A becomes 1. So if A becomes 1, we skip all the ifs and we exit. So our answer here is 1. So again, why did I give this question? I wanted to make sure you understood how these statements are chained together. So what will the below code segment print to the screen here? So a strategy here is, let's block the conditional structures. We can take our pencil and we can connect them. So notice I have an if, and I have an if, and this else is connected to that if, and this if is by itself. So by taking a second and getting a pencil out and blocking these together, it's going to help you kind of navigate this. So first thing I notice here is that at most is I'm going to have 3 things printed to the line, because I'll never go in both this if and this else. So B can go away right away. So let's say if C is equivalent to A, that's true, so we have to print out first line. So that means C can go, that means D can go. And now let's evaluate this condition. If A is greater than 10, is 9 greater than 10? That's false, so we're going to come down to the else, and we're going to print out the third line. And so therefore, I don't even need to come down and look at this last condition here. I know the answer is A. But let's talk it through just to make sure we understand it. This is saying if C is equivalent to A, which is true, and since this is true, I actually don't care about the next one because it's an OR operator. But just to make sure we understand, A mod 3 is equivalent to 0, mod being calculate the remainder when we divide A by 3, and that's true. So this is one that students often look at and they get a little overwhelmed by it. So what values are stored in X and Y after the execution of the following program segment? So again, good strategy here. Get your pencil out, connect the statements. That's why I stress so much this indentation, because this if is inside of this one, and this if is inside of this one. So by connecting them, I see that if this first condition fails, I'm going to jump all the way down to here. So look for the shortest path here. So let's see. Is 30 less than or equal to 0? Well, that's false. So we're going to skip all the way down to here, and y becomes negative x. So if x is currently 30, y is going to become negative 30. And there it goes. So again, good strategy when you're looking at multiple choice problems, and this also goes for when you're coding, is to actually connect take some time and notate the page. Draw some stuff on there to help you out. That's why also too, when you're programming, it's so important that you can indent properly. In Java, the indenting doesn't actually have any functional impact on the program. It's simply a tool to help you organize yourself. It's good to note that if you program in Python, the indenting makes a big difference. So here's multiple choice question 3. I made a little change here. Do you see it? I've essentially switch that condition. So now we're going to go inside of here. So the first step is the block. We're going to connect our conditional statements. And I want you to pause the video and try and work this out now. Okay. So, do you have the right answer, you think? So you should get the answer x equals 30 and y equals 90. Now you might be good enough that you can do that in your head, and that's great, and that's kind of what we're aiming for. But two things here. One is, it really doesn't hurt to take a moment and to notate some stuff on the page, because that's going to set you up for problems that are more complicated. So, multiple choice strategy. We're going to talk about two strategies here. We're going to make notes on the page, especially if you're writing the AP exam and you're trying to do things quickly. Write some little notes on the page as you go. So this is how I might do this. I might put a T here, you see here, because that evaluates to true. So I can ignore that, I'll cross that off. Next condition will evaluate to true, so I can ignore that, so I cross it off. I'm going to work out 30 times 3, which is 90, so I'm going to put y equals 90. That evaluates to false, so I'm going to cross that off. And then my answer is going to be x is 30 and y is 90. Now, so that's one strategy. Get your pen out, write something on the page. It's going to help you. Another strategy is to actually bring a piece of paper, a blank sheet of paper or a ruler, and cover it up and go line by line. This is something that I really struggled with when I was a student, because I would try and look at the whole problem and I'd say, oh yeah, I know the answer, and then guess. And often I'd miss some little ideas, so it actually took a while for me to kind of force myself to do this. So if I was doing a problem like this, and for this problem now I wouldn't, but if I was doing a more challenging problem, I would still do this. I'd get a ruler or a piece of paper and I'd cover each line and move through the question sequentially. So imagine there's my piece of paper. I'd only look at that line. Okay. Then I'd slide it down. That evaluates to true, so I'll slide it down. That evaluates to true, so I slide it down. I work out that value, slide it down. That evaluates to false. And then I'm just going to slide it down, and I'm done the problem. One of the things we want to develop right now is, yeah, we're going to work at ways to look at a problem and do it quickly, and look for little shortcuts. But right now, I'd say a bigger thing to focus on if you're just learning this stuff is to be sequential and systematic about how you attack these problems. Putting these little multiple choice strategies into practice will be really useful if you choose to write the AP exam, because there's 40 questions that are done in an hour and 15 minutes. And these strategies make a big difference and are helpful. So I talked for probably, between the two videos, about 33 minutes. There's a lot here. And the best thing to do now is to go out, open up a program and play around with this. Try and make some basic conditional statements. Another excellent resource is Coding Bad. Always, if you have questions, you can ask me. You can post some questions on my YouTube channel. Thanks for taking the time to watch this, and have a wonderful day.